I'm going to use Geogebra to explain the difference between three types of transformations. A transformation is when a geometric figure changes position, shape, or size. There are three types of transformations: translations, reflections, and rotations, where the image, the transformed image, is congruent to the pre-image. The first of those is a translation. So in a translation, the figure doesn't change shape or size, it simply moves. Sometimes it's referred to as a slide. Vectors are a great way to describe this movement because they specify distance and direction. So let's look over here on this right here. I'm going to click on it and I'm going to add axis. So notice we have corresponding points. We have A here, which corresponds to, in the pre-image, which corresponds to A prime. Notice how they are 4 units across. Those corresponding points, the distance between them is going to be congruent between all corresponding points. D is also 4 points from D prime. B is also 4 points from B prime. C is also 4 points from C prime, and so on. I can use this vector to manipulate this one. I can see that I can slide them all around, and it's not going to change the shape. If I do move 1 point, for this to remain a true translation, that corresponding point in the other shape has to move as well. Now, the movement can be described using that vector. So let's see. For here, I'm going to go here. And now the pre-image and the transformed image are separated by 4 units on the x-axis and 4 units to the right on the x-axis and 2 units up on the y-axis. All right. Now we're going to talk about reflections. A reflection is similar to what it sounds like. The image, the pre-image and the transformed image, here we go, have the exact opposite orientations. Running in between them, if you notice, here, let me look, is a line of reflection. You could almost think about this if you were to have a piece of paper and fold it across on that line right there. They would be opposite images of each other, yet equal. All right. So what I want you to see is that I can change this line of reflection. Here we go. Now this line of reflection is, the equation for this line is x equals -4, and they're still opposite from each other. B is 1, 2, 3, 4, 5 units from the axis. B prime is 1, 2, 3, 4, 5 units from the axis. I could pick any corresponding point. Let me see. C, and it's going to have the same distance from the line of reflection as C prime from the line of reflection. Notice also, one more last note on that, is that the shapes didn't change size. They didn't change size, they didn't change shape. The before image and the after image are exactly the same. They're just opposite each other from that line of reflection. All right, last isometry is rotation. Rotation also doesn't change the shape. It's reliant upon 3 things: identifying the center of your rotation, the angle of your rotation, and the direction of your rotation. Here we go. Let's take a look at this. All right, I'm going to add, oh, I already have axes. Let me put them back. Got my grid. All right, what I've done is, let me see this because you can't see this right now. Here is this is the transformed image. What I've done is, this is the center of rotation. In this case, when the degrees that it's rotating are positive, we're moving to the left. We're rotating counterclockwise. So when it's 0 degrees, notice the new image is superimposed. There's just one image. You're only going to see one. It's superimposed on the other one. As we take this rotation, change it to 90, this went down. All right. I'm going to change it to 180 now. All right, we can see that this rotation took every point across that line right there and rotated it 180 degrees. Did that? You can think of each individual point being connected to that center of rotation and then moving that line 180 degrees. And we can change that to whatever we want. All right, last note I want to make is that, again, the shapes did not change, simply where they were located. That is why these are examples of isometry, because the transformed image is the same, is still congruent to the pre-image. Thanks.